Okay, so this is an inventory cost problem. I'm going to read it to you briefly. Supermarket manager wants to establish an optimal inventory policy for frozen orange juice. It's established that a total of 1,200 cases of orange juice will be sold at a steady rate during the next year. The manager plans to place several orders of the same size spaced equally through the year. The cost of placing an order is $75. It costs $8 to store 1 case of orange juice for 1 year. 1 case of orange juice costs the store $5. Find the number of orders that must be placed to minimize the inventory cost. All right, so this is in your notes. Please make sure you have it right in front of you so that I don't have to keep going back and forth to the problem itself. Let me show you the scenario. So we want to focus on this part right here where it says that you've got 1,200 cases of orange juice that is going to be sold at a steady rate during the next year. So here's a couple of scenarios that I'm proposing. Okay, you'll notice here, a little difficult to read. It's clearer in the other one. So it says max number of cases of orange juice per order. So if you order all 1,200 cases of orange juice and you wait an entire year to sell them, so you're selling them at a steady rate until your entire order has been filled, it will take 12 months, which is a year. This is one possible scenario. Okay, so again, you order 1,200 cases of orange juice, you place it in storage, and then you just consistently sell whatever you have in storage over the course of an entire year. So 1 order of 1,200 takes 12 months. Okay, so here's another scenario. Say you cut that order in half and you sell 600, right? So you only order 600. You sell that 600 over 6 months, and then you buy another 600 and you sell that 600 over another 6 months. So still 12 months, right? But now you have 2 orders of 600, okay, over the course of an entire year. Okay, there's an infinite number of possibilities, so I'm just showing you a few. Here's another possibility is what happens if you were to place an order of size 100. So if you're trying to sell 1,200 total, then you got to do 12 purchases. So you buy 100, deplete it down. The next month you buy another 100, deplete it down, and so forth over the course of 12 months. So if you have 100 as the maximum that you're going to place in your storage facility, then you have to make 12 orders in order to accommodate, and I'll go back to the problem, right, it's right there, the 1,200 cases of orange juice. Okay, so again, I'm going to go back. This is 1 order, and you order all of them, 1,200 cases of orange juice, deplete it to 0. This is 2 orders of 600, so deplete, 6 months later, get another 600, deplete within that 6 months. Here's the last one. Okay, so if you order just 100 at a time, then you have to place 12 orders. So then the question for this problem really is simply, how do you minimize the inventory cost? Which scenario is the best one for us? Okay, this one where you're only placing 1 order, or this one where you're placing a bunch of order, or another option. Okay, so now that we've established that, it's going to be a good idea for us to write down what our variables are. Okay, so let's start there. So we'll let X equal the number of items per order, right? So in this case, this very first case, it was 1,200. There it was 600, and here it was 100. Okay, and then we're going to use R to represent the number of orders per year. Okay, so those 2 variables are going to be vital to what we do next.